All right, the question says, a buffer solution with a volume of 72.3 milliliters is made with 0.00752 moles of formic acid and 0.00941 moles of sodium formate. If 0.214 grams of HCl is added without changing the volume of the solution, what is the pH of the resulting solution? And the pKa of formic acid is 3.74. So just like in the previous questions, we're going to ultimately want to use the Henderson-Hasselbalch equation. And the Henderson-Hasselbalch is pH equals pKa plus log of the concentration of the base divided by the concentration of the acid. In this case, the base is going to be the sodium formate, and the acid is going to be the formic acid. But there's quite a little bit of work to do in order to find all of these concentrations before we can plug into this equation. Specifically, we're unfortunately given the moles of formic acid and the moles of sodium formate. So the first thing we need to do is change those to concentrations. And you'll remember that molarity is moles divided by liters, not moles divided by milliliters. So we need to convert that volume to liters. So the first thing we want to do is find the concentration of HCHO2, formic acid, which is going to be the moles of formic acid, 0.00752 moles, divided by the liters of solution, which is the same for everything, 0.0723 liters. And when you do that math, you find that the formic acid is 0.104 molar. Repeat for sodium formate. The concentration of NaCHO2 is the moles of that, which is 0.00941 moles, divided by the 0.0723 liters, which is equal to 0.130 molar. Now, if this was like the previous two questions, we could just plug these numbers in. This is the acid, this is the base. But here, we've done something to, cause a reaction to occur. We've added some HCl. So we have a buffer solution, and then we disturb the buffer by adding HCl. Well, what is the HCl going to do? The HCl is essentially a source of H+. That's going to react with the weak base, formate ion here, and it's going to form more formic acid. So this is how buffers work. The weak base will react with any added acid to turn the strong acid into a weak acid, the conjugate acid of that weak base, if you will, and that will resist change in pH. If we were to add a base to this, it would react with the formic acid to make more sodium formate, and that would, again, resist the change in pH. But now we need to figure out exactly how much that is. So we need to find the concentration of HCl. But for the concentration of HCl, we don't have moles of HCl, we have grams of HCl, so we have to do an extra step. We have to take the 0.214 grams of HCl and convert it to moles by using the molar mass. 1 mole of HCl is 36.46 grams of HCl times a unitless 1, that moves the moles over, and we divide by the volume in liters. It's the same volume as before, 0.0723 liters. And when you do all of that math, you find that it is 0.0812 molar HCl. So now we have the concentrations of all these things. So before we add the acid, if you will, the concentration of H plus is the concentration of HCl. Because this is a strong acid, it completely dissociates into H3O plus and Cl minus, or just H plus. So I'm going to leave it as H plus here, which is 0.0812 molar. Before the acid, the formate, in this case we have it in the form of sodium formate, is 0.130 molar, and the concentration of formic acid is 0.1104 molar. All right, I didn't need to write the molars here because I have the molars as the headings, so they would know the units of everything, so I'm not going to write them moving down. So if we look here, what we see is that there is more formate than there is acid. So that means we're going to use up all of this H plus. Whoops, I said I wasn't going to write it and then I did, which means at the end of the reaction, we won't have any left. But now we need to think about what happens to the formate. What happens to the formate is it gets used up in the reaction as shown here. So we lose 0.0812 molar formate, and we gain 0.0812 molar formic acid, because this much formate, based on the amount of HCl is added, is turned into formic acid. So, said another way, adding the acid will lower the pH of the buffer, but it won't lower it as extremely as if we, for example, added acid to just water. So, what happens here? The final concentration of the formate is 0.049 molar, and the final concentration of formic acid is this plus this, which is 0.185 molar. So what did we do? We took away some formate because it reacted with the acid that was added to the buffer, and we formed more formic acid because that's how the buffer resists the change in the pH. It turns H plus into formic acid. It turns a strong acid into a weak acid. How do we figure out the pH? Well, we do that exactly the same as in the previous problems. The pH is going to equal the pKa, which is provided to us, 3.74, times the, not times, plus the log of the concentration of the base, that's the formate, which is 0.049 molar, divided by the concentration of the acid, which is 0.185 molar. Note that we have more acid than we do base, so we would expect this pH to be lower than the pKa. And sure enough, when we do this math, we find that the pH is equal to 3.16, which is lower. So we added 0.082 molar HCl, and the pH is slightly decreased. That's how a buffer works. It resists changes in pH by having a weak base turn into a weak acid, or if you had a base, having a weak acid turn into its weak conjugate base.